What's up, everyone? It's me, Miss Wesley, and it's hard to say this, but we are really wrapping up the statistics unit. And we had started discussing yesterday the concept of a normal distribution and talking about how a lot of times real life data comes out to be distributed normally. And if that's going to be the case, if you see that, we can use something called the empirical rule that 68% of the data falls within one standard deviation of the mean, 95 falls within two standard deviations of the mean, and almost all of it, 99.7, falls within three standard deviations of the mean. So tune on back in to page 24 in the middle, and there's just a couple examples we left out that I thought would be good to practice and solidify these skills. A little joke, did you guys hear the rumor about butter? I shouldn't tell you because I shouldn't spread it. It says in the middle of this page, last page of the packet, can hardly believe it. The scores on an Algebra 2 final exam come out to be about normally distributed, with a mean of 150 points as a score on the exam and a standard deviation of 15. For starters, because we're going to be asked 3 questions about this data, and because we see the word normally distributed here, that's our license to create our own bell-shaped curve here, and we're going to label it up with 1, 2, and 3 standard deviations above and below the mean. So I have a scale that I already drew, and I want to space out a nice bell-shaped curve underneath of it with the mean right in the middle. So the mean average score was a 150. And let me get some lines here for 1, 2, and 3 standard deviations above the mean and 1, 2, and 3 standard deviations below the mean. Feel free to pause, fill this in yourselves, and answer the questions. Tune back in. I will add, 15 a couple times. So we'll go 150, 165, 180, and then 195. Now we want to subtract the standard deviation a series of times. So 135, 120, and 105. So I'm hoping the questions below are asking about some of these scores that we wrote here. For practice, can you put the percentages in too, right? I just want to get these numbers kind of get into a rhythm with them. Your middle 68% can be split in half to be 34% and 34% of the data. Next up, we know because of the empirical rule, 95% is going to fall between 120 and 180. So if I took 95% minus 68, I get 27, half of that, 13.5% and 13.5%. Okay, then if you recall the numbers a little bit further out, 2.35 and 2.35, can I squeeze it in there? And then a point, just in case we need it, a 0.15%, put the percent there too, and a 0.15%. Okay, now let's see which of those numbers we actually need. 13, what percentage of students scored just as above a 180? Well, you know what? That's this upper tail. That's going to be the sum of these two values. So I would say 2.35% plus 0.15%. And that's going to give me a total of just 2.5%. That is one way you could get that. Now, I say one way because think about it. We know 50% is up above this mean, right? So you could have done 50% minus the sum of these to still get 2.5%. Just another way to think about it. 14 says if 250 students took the exam, approximately how many scored above a 135? So that's below the mean. That's everything from 135 on up here. We would want to get the percentage first. So one way to do it is to add, I think, those 5 percentages. Let's give that a try. So the 5 percentages are, well, a 34 and a 34. I know that's 68 to save some room. We're going from 135 up. So 13.5 plus 2.35 plus 0.15 gives us the plus 2.5 that we had from the problem right above it. And that's going to be a good amount of the students, 84% to be exact. Now check the question. It didn't ask for a percentage here. It said how many scored. So we need 84% of 250. So 0.84 times 250, that's an easy calculation, and you get an approximation of 210 students. I'll just say 210 there. All right, 15. If 13, now this is an interesting question. 13.6% of students received a B on the final. Could you tell me if these are the grades and it's a bell-shaped curve, where do the B's fall? Could the B's be anywhere on this curve? And I say no. If your grading scale goes from the top scores being an A down to the bottom scores being an F, Right in the middle at the mean, this is going to be your C range. The mean is where the C's are going to fall. The B's need to fall above it. And look, 13.6%, that's roughly around that 13.5. And this little chunk here looks like it falls in the perfect B range. I'm going to make a couple conclusions here. And because that 13.6% is so close, I'm going to say it should be around the range that's pictured here at 165 to, what is it, 180. Around those scores should be your B's if that's the percentage that you're getting. And I'd say for a normal, to explain it, for a normal distribution, the C is right in the middle. The B's have to be on the right-hand side. They have to be on the upper end of the curve, and the percentage just about perfectly matches up for those scores to be your B's. Okay, lastly, grab the calculator because I want to do one final statistics exercise with you as a class. I took a bunch of scores on a recent calculus test, 26 scores to be exact. I want you to pause the video, get these scores typed into your calculator, into your L1, and in a second together, we are going to sort the list and just do a little review, answer a bunch of statistical questions about this list, and see if the data looks normally distributed to you. So go ahead, type them in. I've got them here. I want to sort the list. So stat, sort ascending, L1, get it in order. Now when I go back to my list, it's going to be much more convenient because the grades will be in order from low to high. I see the low is a 60. And how's the data looking just by looking at the numbers? Seems like the mode, there's 7 grades of 90. I want to be optimistic here and say if it were skewed one way or the other, it's skewed toward there being some higher scores, higher values, so it's slightly skewed left, but maybe about normal. Let's look at a histogram or a box plot to make that guess. So I'll go second and y equals. I'll go box plot first, and I'll hit enter. I'll turn it on and choose the box plot that I like, the one that would show outliers if need be, and I'll hit graph on a zoom 9 for graphing L1. This data does, especially if you don't count the outlier, it kind of does look like a nice bell-shaped curve. 50% of the data falling in this middle box, and then those two perfect, look at how symmetric those tails are, about this lower 25% and that upper 25%. So I want to say yes, it looks about bell-shaped, maybe with a few more grades up in the high range. And that's because you've got this nice box in the middle, lots of scores there, and approximately equal sizes of tails above and below it. For fun, we could look at a bar graph, a histogram, that'll place those values in bars according to their frequency. So I could go second and y equals. I'll just go back into plot 1. Choose the bar graph, choose the histogram, and I'll do a zoom 9 again. So I can see, you know what? It kind of does look like a bell could trace that curve out where you're slightly skewed to the left, but let's see how normal this is going to look. Okay, so now I got to fill out the table with the statistics. I can use a stat, calc, and then one variable statistics for L1. Okay, and I'm going to scroll through this just to review and refresh some of my rounded measures of center and spread, and I'll copy them into the table here, okay? So the mean it gave me was 85, the average grade. Pretty good for a test, an 85. Median, middle grade, was an 87.5, and the mode I had to count up while those values were in order, 7 grades of a 90. So there are my measures of center. Your 3 classic measures of spread, the range. Well, I can tell from this table, the values go from a 60 to 100. The range was a 40-point swing. You know, I had some good variation in the grades on this test. Standard deviation, I'm going to use population standard deviation, and I'll square it myself to get variance. So standard deviation rounded to the nearest hundredth was about 10.56. And when I square that value, I'll just do nearest 10th for this. 111.5. So on average, my data values are varying about 10 or 11 points above or below the mean. If we got a yes to question 16, let's just see what the data would look like under a normal bell-shaped curve. Let's draw this distribution. So you have your mean right in the middle, and that would be 85. You're going to add 1, 2, 3 times. You're going to add this standard deviation, the value that I circled, the 10.56, and I'm going to round to the nearest hundredth. So I'm just going to add, or 10th. So I'm just going to add 10.6 to 85. So 85 plus 10.6 gives me 95.6. If I add 10.6 again, 106.1. That's a smooth jazz radio station, if I recall. And then 116. Actually, I don't think it's smooth jazz anymore. I think it used to be, and now it's like smooth R&B hips or something. And then 68. Okay, let me subtract. Let's stick to the math here, and let me subtract 10.6 from 85 a few times. So I got 74.4. I got to the nearest tenth, 63.9, and then almost all of the data falling 53.3. If we're buying that this distribution is roughly normal, and I said, quick, tell me how much of the data is probably going to fall between here and here, you're going to say almost all of the data. The empirical rule says 99.7% falls in there. And speaking of percentages, I mean, we know the 68 has to fall. This middle is going to be 68. 2 above and below is your 95, and then 3 above and below, we just said, is 99.7. Let's test those out with actual values. Keep your calculator close by. How many scores are actually within 1 standard deviation of the mean? So I gotta look. How many scores, let me circle these in red, fall in the range from 74.4 to 95.6. On my calculator to my sorted list here, and I see, okay, so the low value is 74.4, and check it out. We've got 4 values that are below a 74.4. So remember that number 4. I'll jot it here just in case I forget. Now we want to pick, and I'll scroll down to the bottom of the list, to my high end, to see who was lucky enough to fall above a 95.6. Not those 95. So 1, 2, 3, 4 100s that fall above it. So 4 plus 4 are the values that fall outside of this shaded range. So that's 8 values. There were 26 total kids in the class, so 26 minus 8 gives me 18 actual scores that are within 1 standard deviation above the mean. I wonder how close this percentage would be to the empirical rule, to the 68%. So 18, let's see the percentage. 18 out of the 26 total test takers. Do that calculation, see what you get, about 69.2%. So not too far off from what empirical rule would have approximated for us. It would have said 68. We got a percentage point above that. Let's test it out for 2 above and below. So how many people are getting below a 63.9 and above a 106.1? Well, no one. Let me just look at the list here. It's probably easier right on the packet. No one's getting above 100. So no one's higher than 2 standard deviations above. Who's below a 63.9? So this 60 here, was there another 60? No, I don't think so. So one of the values fell outside of that, meaning the other 25 test takers met this requirement. So 25 out of 26 were the amount of scores that were within 2 standard deviations of the mean. Now, according to empirical rule, approximation is going to be 95%. You get slightly higher than that. 25 out of 26 equals a 96%, a 96.2%. So close to empirical rule, but not exactly. I'm not even going to bother asking you 3 above and below, because luckily no one got below a 53.3, and luckily no one got above a 116.68, because that would be too easy of a test if someone got that high. So 100% of the data actually falls within 3 above and below. Okay, it's been my distinct pleasure to hang out with you, and I'll talk to you later. Have a good day.